This is Digital Pathology Today. Now, here's your host, Dr. Joseph Anderson.
With digital pathology, we are utilizing new methods to view images acquired from a very old technology, that is, H&E stained sections from formalin-fixed paraffin-embedded tissue, which have been prepared the same way for over the past 100 years. This method actually adds steps, time, and expense. But what if we could reinvent the way we process tissue to instantaneously view images from tissue without having to process and fix these tissues in the traditional way? Can we move beyond paraffin? Welcome to Digital Pathology Today. I'm Joe Anderson. David Tulman is a biomedical engineer, cancer researcher, and entrepreneur. He earned a PhD in bioinnovation from Tulane University, focusing on the development of novel microscopy systems for point-of-care pathology evaluations. David is a founder of Instapath, a company formed in 2017 to build and commercialize systems that image pathology tissues without fixing or cutting. Built on the vision of better patient outcomes, Instapath introduces an innovative solution utilizing optical scanning microscopy to evaluate the composition of an entire fresh tissue sample within minutes. David is also the host of Beyond the Scope, the podcast from the Digital Pathology Association. We'll talk to him about that, as well as the upcoming DPA annual meeting, Pathology Visions, this October in Las Vegas.
Today's podcast is sponsored by Motic Digital Pathology, creating the systems that move pathology forward.
David Tulman from Instapath, welcome to the podcast.
Thank you so much, Joe, for having me. It is an honor to be here.
Yeah, we're glad to have you, and I think our listeners are interested to learn more about you and Instapath. So tell us a little bit about the history of Instapath and what you've been working on there.
This started as part of my PhD project, which I did at Tulane University in New Orleans. I joined a lab that was specializing in innovations in microscopy technology. We were developing a novel scope at the time that could provide like a really unique way to look at tissue. So looking at tissue with histological relevance, but without any of the fixing or any of the cutting. We started developing the technology back in 2012 and did some initial clinical validation studies at Tulane as part of my PhD. And then around 2016, 2017, my business partner and I got into a nationally funded program by the NSF called ICOR. And ICOR actually gave us $50,000 to travel around the country and talk to physicians about this technology we were building and how it might be used. Throughout these travels, we traveled all over the country. We talked to about 200 physicians. We got this signal that in the field of digital pathology and just like pathologists in general, we're looking for new innovations that would be like the next generation of digital pathology. If you remember 2016, 2017, that's around the time that slide scanners were first being adopted in the US because that's when the FDA allowed those to be legal medical devices. We were talking to all these pathologists and they said, we think the idea of slide scanning is really cool. We think that this is the future of digital pathology, but can you take this a step further? Now that we've got the digital images, can you take out some of the laborious lab work that goes into it? So, all of the fixing, all of the cutting that takes such a long time, and some institutions in some settings can delay diagnosis. So we ended up talking to a lot of pathologists that pointed our technology in that direction. Like there is a need in pathology for a digital system that can not only scan slides or scan tissues, but do this without fixing and do this without cutting. It was at that time that we decided, hey, I think we might have a business here. We need to spin this off from the university. We need to license the technology to a company that we make. And we made Instapath so that we could do that. So we're still pretty young. We've been operating since 2017. And we moved to Houston to the Texas Medical Center space in 2019.
That's a great story. So I think as pathologists, we're all acutely aware that we're in the midst of some kind of digital transformation. And yet we're stuck with the old technology for making the H&Es, the paraffin tissue blocks, which is, it's fascinating because I think a lot of how medicine works, or even progress in general, is by incrementalism, right? You have an old system and then you try to adapt or put new changes on top of it. And so, but with digital pathology, so we have this old way of doing things, embedding tissue in paraffin and then cutting it and creating glass slides and then scanning these slides. It actually adds steps to the process. And so it's cumbersome. It makes the whole process more expensive. That's a key question. How do we bring tissue processing and acquiring these images? How do we bring that up to speed into the 21st century and make that compatible, with the workflows that we want to see? I mean, the old technologies worked incredibly well, and it's amazing how long it's been here. I just saw a thing on 60 Minutes showing the old Armed Forces Institute of Pathology, or what's now called the Joint Pathology Center, and they were talking about how they sequenced the Spanish flu from 1918, and they showed tissue blocks. And I'm sure, pathologists, so it's a nice bridge to the past, right? It's a way to store tissue. It's robust, or I should say we've developed robust methods around it. So surprisingly now we can do everything with paraffin. Make the H&E stain, we can make IHC, we can even extract DNA and RNA from it. It's incredible how well it's worked, but I think most would agree it's time to move on, or it's time to come up with something that is going to be more compatible with a digital workflow. So kudos to you. And so what's it like, running a startup in this industry? I think you have a unique challenge, you're the technological challenge you're trying to solve, but then the business aspect of it. You talked about how you went about starting the company and the various stakeholders you've interfaced with. So, what's it been like?
It's equal part challenging and exciting. Maybe we can start with the exciting first, because the really exciting part is pathology really hasn't been innovated on for 100, 200 years. This is an opportunity to make new things that are going to significantly change the way that pathology is done. The really, really exciting part is being at the forefront of this change in both technology and both mindset of pathologists, and having the opportunity to talk to the people that are going to be the early adopters of this technology and actually have a say in what the new workflows are going to look like. The challenge with that is almost the exact same thing I just said. When you innovate, you need to identify who your early adopters are, and you need to ask them, okay, we're going through a change in mindset. We're giving these new technologies that's going to make your job more efficient, or that's going to make the tests that you do, it's going to make your reads more accurate. We have to ask them, what do you want the workflow to look like? And the reason why this is so challenging is because, especially in the US, digital pathology adoption is in its infancy. Pathologists, the users of these new technologies, really don't know what the new workflows should look like. So it's really challenging, because as innovators, we have to find the right questions to ask. On the other side of pathologists, the ones that are ultimately going to be using these new technologies and finalizing these new digital workflows, they have to really be creative and really think outside of the box. And they have this wonderful opportunity to imagine really new workflows that can make their lives more efficient. It ends up being these oftentimes really uncomfortable conversations where I'm not quite sure the right questions to ask. I'm trying to ask pathologists about, how do you envision this workflow? And they don't know how to answer the question, because we're in such the early stages of these digital pathology technologies. They have a hard time imagining what's possible.
That reminds me of a story about Henry Ford said, when he invented the automobile, or when he mass produced the automobile, if you ask the average person what they want, they would say a faster horse. Right. So it's like the automobile was on nobody's radar screen, right, in the early 1900s. And a few years later, everyone said, well, obviously, this is what we wanted. Right. It's just kind of a question of how do you get from not having it to having it. It's challenging and exciting. I think that's a great way to put it. And it is a great opportunity. Paramount is the workflow, right? What is the average day going to look like for a pathologist? But then there's other considerations, like what do we gain, from new methods? What do we lose, not having that tissue locked up in paraffin? So maybe just tell us, what do you envision, or what are the features that we want to see or want to incorporate into this next generation of microscopy technology?
The first thing is simplified and more efficient tissue processing. at Instapath, we build scanners that have the capability of imaging surface of tissues without having to do any fixation or any cutting. If you talk to the large academic centers here in the US, they don't have a problem. They don't really have a problem with fixation or cutting. They have really good, established, efficient procedures to do that. So, you can turn around an H&E slide in 24 hours if you really want to. But on a larger scale, if you look at pathology in more rural areas of the US, or getting outside of the US, more rural areas of the globe, there's not a lot of practices that are good at tissue processing. There's a lot of deficiencies when it comes to processing tissue into blocks and cutting them to get a good and accurate diagnosis. So I think the first step is really simplifying the tissue processing and providing some level of automation so that anywhere in the globe we can provide an opportunity for an institution to get a good image. And that's the second piece of this, is moving away from glass slides and diagnosing from images. So doing this on the computer. If you are able to automate tissue processing, if you're able to make it much simpler and you're able to use new generation scanners to get these images, that may solve a global pathology shortage problem.
There is this problem of the looming global pathology shortage, or just not the right pathologists where we want them. It's interesting. So we said the workflow is probably paramount, but then so many other considerations, deficiencies, as you said, in H&E processing, I think it's going to become more of an issue as we go forward, not less, because I think, pathologists were trained kind of with the adage of a poor carpenter blames his tools, right? So you had to make do with, it was just part of the game, so to speak, that, some days the tissue processing was going to be good. The thickness was going to be okay. The pinks and the purples were going to be the right hues. And that's not really what you were looking at. You were looking at more of the features. But now, as we move to a digitized system and incorporate computational pathology, the colors are going to have to be crisp, spot on, and uniform and accurate and true. So I think that's going to become even more important. And so it really highlights the need for a new approach. Incorporating the computational aspects are going to become, the image quality is going to become much more important.
And that's the current challenge that new generation scanners are facing. And when I say new generation scanners, I'm saying what comes after digital slide scanners, that the whole slide imaging systems that we see today. And that's these new microscopy systems that have the ability to optically section at the resolutions that's needed to make a lot of diagnoses in pathology. So the challenge that these next generation scanners are facing is that consistency issue. Because if we're going to go digital and if we're going to automate more things, we should also be able to consistently produce the same quality of image every time with the same coloring, so that maybe the next step after that is we can automate some of the feature recognition. But to do that, we really need good, consistent images with consistent coloring. And that's something that in the current workflows, when you cut up the tissue and stain it, that's really hard to do.
So we might make the workflows more efficient, right? We might get rid of paraffin, we might get rid of glass slides, but what does it mean for outcomes? How is a new approach going to advance precision medicine?
I think that's the next big question that we want to try to answer. The way that I look at it is that there still might be a place for paraffin. There still might be a place for slides, but how do we get the most out of one diagnostic sample? Imagine patients that are going in to get a prostate biopsy. I think the standard is now what you take between 12 and 24 18 gauge cores. That's a lot of diagnostic material you're taking. And it's because we have these wonderful opportunities right now to do molecular testing, genetic testing, to get an even more specific diagnosis than just Gleason 3+4 prostate cancer. We can now do genetic subtyping, molecular subtyping. We can get a specific profile about this prostate cancer that will help us use these wonderful new therapies that target those genetic or molecular aberrations. But the way that the workflow is now is we need to take a lot of diagnostic material to achieve that. And in prostate, that's something you can do. It's maybe not as big of a deal. When it comes to brain biopsies, that diagnostic material is precious. You may only be able to get one 20 gauge biopsy. And from that 20 gauge biopsy, you need to get as much information out of that sample as possible. Unfortunately, the way that we currently process tissue through fixation and through cutting, or if you're doing frozen sections, if you're using the cryostat, we destroy a lot of that diagnostic material. So as we're building these new scanners and designing these new workflows, we need to consider these samples really precious and really try to come up with ways of how can we get the most diagnostic results out of a single sample. And I think these new generation scanners that are trying to bypass the fixation and the cutting is one approach to really be able to run a lot of tests on these samples, be able to multiplex, and maybe this will result in less invasive procedures.
Tissue, I think you're exactly right. It is precious. Our current methods of doing things have worked very well for most patients. But, you hear horror stories or where we can't do the predictive and prognostic testing. We can't do the ancillary markers because, lo and behold, the tumor disappeared on deeper sectioning, right? We wasted it. It's possible to have small amounts of a high-grade tumor. Small amounts of tumor don't necessarily correlate with a better prognosis. For whatever reason, you could detect an aggressive tumor early in the process, or maybe you just missed it. Particularly in prostate cancer, we can see foci of 2 or 3 glands. And, how do we best utilize that tissue to get the best information for the doctor and the patient? You hear horror stories of patients going back to the OR to get a biopsy just to get the biomarkers because we couldn't do it for whatever reason on the first pass. So it's not trivial.
Just one quick comment on that. When I was going through the I-Core thing and talking to all those physicians, we heard those horror stories. So it was those horror stories that really is one of the main motivations as to why we're going down this endeavor with Instapath.
My question, or 2 questions, is one, what's going to happen to the tissue, right? Are we still going to keep it? Is it going to stay in some kind of medium like paraffin or something like that? I mean, there's certainly regulatory requirements about how long you need to keep tissue, and certainly if it's going to be useful for the patient, we want to keep it. And all of much of our information regarding prognosis and prediction is locked up in molecular tests and IHC, which consume tissue, right? So we have these tests that consume tissue, and B, we're probably not quite ready for prime time in terms of prediction and prognosis based off the H&E image. So we might be able to develop these unique tools to avoid tissue processing, but realistically, how soon is it going to make sense to implement this in clinical practice?
I think we're looking at that happening in maybe 5 to 10 years. We're a ways off from being at a comfort level of being able to do this. We're going through a period right now where scanners like ours and these next generation microscopy scanners, we're doing the clinical validation tests right now. The blinded reviews of our digital images on unfixed, uncut tissues versus H&E. And we're developing methods to, hey, maybe we can do some of these IHC tests without having to do any of the fixation or any of the cutting. But I still think that there's a long road to get there. Once some of the early adopters do get to a comfort level of diagnosing from this unprocessed tissue, I still think the first adoption of this is going to be some type of intermediate. I still think there's going to be, okay, maybe we're going to do like initial tissue triage, initial H&E, or like initial frozen section on these unfixed, uncut tissues. By the way, this new way to stain and scan tissue, at least we've found, does not impact the downstream results. So maybe we're going to save that tissue. Maybe we're going to go ahead and put it in paraffin blocks, and we're going to keep that block in case we decide we want to do more tests on it in the future. I agree with you. I just think it's going to take a long time to get something like this fully adopted, but the technologies exist out there to make it worth trying.
I think most would agree. We're going to get there someday. It's a matter of how and how soon. So what do you think a new workflow is going to look like?
In my ideal world is that a biopsy, or take a piece of diagnostic tissue, put it in a box that has a scanner. You can press a button and the image that you want pops up, and it's got the diagnostic information that you need. That's what the workflow looks like in my ideal world at a very, very high level.
That sounds fantastic. So I think that, that's what it's going to look like. And then the other piece is, all the information is digitized. The images are digitized. It can live in the cloud to some extent. And we talked briefly about global shortage of pathology. How is this going to change practice of pathology globally, with the ability to capture images like this and then link pathologists around the globe to share and collaborate?
Let's talk about an example of how this could be used in the U.S. first, on a smaller scale. I've talked to a lot of pathologists, and Joe, maybe you share similar experiences that you're doing an evaluation of a organ donor for liver transplant. The surgery the donation is happening in New Orleans, Louisiana, which is where I did some of this work, and the donor is located in Missouri. The donor is located at an institution that doesn't have a cryostat, or they don't have a tech to do a frozen section. In order to evaluate this donor properly, you have to get a diagnostic biopsy to a cryostat machine and use the pathologist the expert pathologist that's at this hospital in New Orleans to check for adipose, because that's one of the criteria for liver donation. It's a really inefficient process. You have to get the entire patient to New Orleans, take a biopsy, call in an expert liver pathologist in the middle of the night to do a frozen section. I think with new technologies, there's an opportunity to do a lot of this remotely, and then you can just get the organ to New Orleans to do the transplant. I wonder if you've had any experiences with being called in the middle of the night to do like a transplant evaluation.
Thanks for bringing that up. I think that really highlights the many, many, many use cases of pathology and kind of the work pathologists do behind the scenes that many people may not realize. And I think a lot of it has been hindered by geography. Things happen in all corners of the world, and pathologists, unfortunately, are usually situated around major metropolitan areas and so forth. So, absolutely. I think in my first job as a practicing pathologist, I spent a lot of time driving long distances to do frozen sections, driving an hour each way, and then sitting around there, maybe saying hi to the doctors, having a coffee in the doctor's lounge, So by the time it was all said and done, it was 3 or 4 hours to do a 15-minute procedure. Not that it wasn't completely necessary for that patient, but in terms of the pathologist's time and the economic argument, I think it was highly inefficient. For organ transplants, I think people may not realize that. When I did my residency training, it was in Chicago. A lot of it, even in a place like Chicago, a lot of it's geographically dependent. I remember the couriers rode these motorbikes, and they had a cooler on the back, on the back of the motorcycle. A lot of it was getting the right biopsy to the right academic medical center to do these. A disproportionate amount of the efforts were probably related to the transport and the logistics of it rather than the looking through the microscope. So yeah, I agree. There's huge potential here to get some efficiencies.
So now let's expand that thought to the global scale. I always use the example of pathologists in Uganda that I've spoken with about this problem. In a country like Uganda, they have 17 total pathologists in the country for a country of 40 million people. 16 of those pathologists are in one large city. They have clinics around the country of Uganda that can do biopsy procedures, but they don't have pathology departments in those clinics. So while they have the means to do the procedures, it's really, really difficult for them to get diagnostic material to one of those centralized locations. So you end up having the majority of the population that just doesn't get access to a diagnosis. With new technologies, they're already doing this now. There's studies published from countries around the globe fortunate enough to have cryostats and to have vibratomes to actually make the slides. They may not have the pathologists, but they have the technical skills to make the slides. They're fortunate enough to have digital slide scanners now, and they're able to share images with pathologists in India or at Harvard or at MD Anderson. So we already have the remote connectivity, and I think the next generation of scanners are going to, in a way, provide tissue processing expertise, tissue processing automated to these areas that just don't have the means to process diagnostic material into an interpretable entity. Now I think in the future they're going to have these technologies that can act as a very skilled histotech and produce an image that if you want to get a biopsy in a rural area of Uganda and your 16 pathologists are centralized into one city, you're going to be able to get a diagnostic entity to that pathologist so that you can expand the people that get access to a diagnosis.
So not only is this technology going to make life easier for us and enhance our workflows, but really I think one of the main benefits may be increasing the care worldwide, especially in underserved areas. David Tulman, thank you so much for being with us. Now, before we wrap up, you're a fellow podcaster yourself with the DPA, so maybe tell us a little bit about that, your experience there with the podcast, and then tell us about the upcoming meeting for the Digital Pathology Association this year in Las Vegas.
I serve on a couple of committees for the Digital Pathology Association. We decided to start a podcast around this time last year. It's called Beyond the Scope. You can find all the episodes at www.digitalpathology.org. We do this as a video format. They're also listed on Apple, Spotify, all those wonderful platforms where you can get your podcasts in audio format. It's really similar to this podcast. It's another opportunity to get the people that are innovating in digital pathology, the people that are really leading the way for adoption around the world, to come in and have these long-form conversations about what are the challenges behind adoption, what are the new technologies that are coming out. We also talk about regulatory issues, and it's really just everything about digital pathology innovation. I host it with Giovanni Lujan, he's a pathologist at the Ohio State University, and he is one of the first pathologists in an academic setting, at least, that is exclusively diagnosing on digital slides. So no microscope in his office. So it's really cool to be able to host the podcast with him.
Ohio State, I think, has been one of the trailblazers in terms of going digital.
Also my undergrad alma mater.
Oh, okay.
It's just really cool how that connection happened to turn out.
Good connections. And then tell us about the upcoming meeting this fall for the DPA.
We have the annual Pathology Visions Conference that's happening the weekend of October 17th in Las Vegas at the MGM Grand. It will be in person. We did it virtually last year. It will be in person this year, which will be really exciting to see everybody. And one of the cool things that we're going to be highlighting at the conference is the impact that digital pathology is starting to have globally. So what we're asking for is for people to submit videos on the Digital Pathology Association website. Just submit short 1 to 2 minute videos in your environment about how you're using digital pathology. Our aim is to collect all of these videos, put it together, and give like a highlight tape showing how digital pathology is being used around the world. And we're also going to select the top 3 as kind of winners of this contest, and we'll show their videos in full and offer some prizes to them as well.
Well, that sounds wonderful. That'll be a great resource. How is digital pathology being used around the world? I'm looking forward to seeing that. So before we wrap up, tell us, what excites you? Where do you see the field headed in the next 10 years or so?
The number one thing that excites me the most, and this has been one of the main themes of our conversation, is global connectivity for pathology. It's on one level connecting pathologists around the globe. So if I'm a practicing pathologist in Uganda and my expertise is in breast cancer pathology, but now I'm starting to see a lot of patients with prostate cancer, I can easily connect and share diagnostic images with that expert pathologist in prostate cancer at Harvard. Connecting pathologists together to pool all of the expertise together to do a really thorough job of diagnosing disease. And then the second thing is giving more patients on a global scale access to diagnostic services. And that's in the next 10 years. I think we're going to start, as we start to see these digital technologies adopted more and we start to see these workflows get more efficient, I think we're going to start to see more patients around the globe actually get access to pathology services that they haven't had before.
That is a wonderful goal. More patients around the world getting access to high-quality pathology services. Our guest has been David Tulman from Instapath and the DPA. We'll see you next time on Digital Pathology Today.
This has been Digital Pathology Today. Please be sure to subscribe. Thanks for listening.